My name is Mohammed Bashir. I'm a professor in structural engineering at the University of Leeds. It's a pleasure to be a participant and a speaker for the India Construction Week. And my talk is entitled Technology Enhanced.
Hi everybody, thanks for joining and listening to me. First of all, I want to introduce myself. My name is Uğur Erşen Şenbil and I am from Turkey. I'm a chemist and completed my master and PhD education based on cement and concrete chemistry and chemicals. I have worked in Fosroc Construction Chemicals for 8 years as a technical manager. And now I have been working in Akkim Kimya for 1 year, which is one of the largest chemical company in Turkey.
My name is Mohammed Bashir. I'm a professor in structural engineering at the University of Leeds. It's a pleasure to be a participant and a speaker for the India Construction Week. And my talk is entitled Technology Enhanced Education, Training, Research, and Management for Post-COVID Revival of the Construction Industry. This talk is co-authored by Harshita Garg, Kai Yang, and Leon Black from University of Leeds, and Srijit Nankutan, Danny McPaulin, and Amy McCabe from Queen's University, Belfast. The outline of my presentation is as follows. I would like to give first an intro into productivity challenges in the construction industry, then discuss some technological innovations that could help to improve the productivity, followed by a discussion on education and training, and finally to conclude with some recommendations. So first of all, the productivity challenges in the construction industry. As you can see from this graph, there is a productivity gap between construction sector and the rest of the industries. And McKinsey and Company in 2017 estimated that this could be of the order of 1.63 trillion US dollars. So you will see that in the next graph, the difference between the growth from 1995 to 2014 in the construction sector in blue and all of the sectors together. So naturally, the growth of the construction sector can be better. And what are the roots of the productivity problem? According to Disperse, a company which is now focusing on improving productivity, it is systemic industry-wide productivity challenges which tie us to the status quo, organizational productivity challenges that affect business units from headquarters to project level, and which limit construction businesses from achieving economies of scale. And finally, personal productivity challenges that bog down staff at an individual level, slowing down delivery and making the job less satisfying. What did COVID-19 do to the construction industry? Initially, there was the loss in construction activities due to the stoppage of all construction activities. And slowly, it was realized that there is the need to revive the construction industry because investing in infrastructure projects would help to re-engage the construction workforce and drive the economy forward. So currently, many countries are at a phase of investing in infrastructure projects to kickstart the economic growth. So the objectives of my presentation today are to demonstrate how construction productivity could be improved, particularly focusing on COVID-19 safe activities on site. To introduce a range of research and innovation in construction materials and technologies which could improve construction productivity, and to share some ideas in education and training to help improve the quality of workforce and thereby the quality of the infrastructure projects. So let me give you a summary of the building productivity through technological innovations. And first, the precasting and 3D printing. These are two examples from India where precast concreting is used to construct residential houses. The first example is from Uttar Pradesh and the second one is from Kerala. In both cases, the facilitating factors are the fact that we have high strength, high performance concrete now available. The admixture technologies would facilitate the construction of prefabs. Advances in fiber reinforced concrete and pre-stressed concrete would enable this. And there is improved understanding in structural connections to facilitate the connection of structural prefabricated units. And of course, there is the improvement in construction workforce that would be required for this type of work. So from a change from the cost of construction at the beginning to whole life cost and life cycle analysis, that also helped in going for precast concrete manufacturing. And if people are now aware of or concerned for the sustainability, that also is driving this. Another area is the flexible arch. It is used for small to medium span bridges. It's an example from Northern Ireland. You can see from here, the flat pack precast units are brought in, lifted, placed in to form the arch, and then tied together to get the bridge needed. It is patented and of course, promoted through a precast concrete industry in Northern Ireland called Macrete. It's successfully used for spans up to 18 meters, highly cost-effective and durable, and bridges can be instrumented to obtain performance in service. Now, the second technology is the 3D printing. As you can see from here, from 1997 up to now, there is an exponential growth in the use of 3D printing and additive manufacturing. It is becoming an attractive concrete technology. And the reasons are, there is no need to use formwork, less labor used, there is a saving in construction time, there is better working environment, less construction waste, reduces the risk in construction, and it reduces the overall cost. All of them would facilitate the 3D printing to become a technology for the near future. You can see the world's largest 3D printer building in Dubai in 2019. It's a two-storied 3D printer building constructed by a US-based company. It used local materials and it is efficient in insulation, hence reduces the energy consumption. What are the facilitating factors for going for this 3D printing technology? Of course, one is the advances in material technologies. Second one is the advances made in building information models, construction robotics, artificial intelligence, and construction informatics. So just wanted to have a brief chat about construction robotics, artificial intelligence, and construction informatics then. Construction robotics would become the new normal because with advances in technology, robotic technologies are widely used to achieve greater efficiency in the performance of construction tasks and also to improve working conditions in the construction phase. The market drivers are high level of construction growth expansion activities, unsafe environment, which would result in injuries to labor, and like what we have faced recently, any pandemic could bring in uncertainties. And it can be used for different construction activities such as structural demolition, bricklaying, assembling prefabricated components, welding, construction of roads, unlocking of different advanced design possibilities, carrying out aerial surveys of structures for different applications construction robotics could be used. Here is actually another example where the image-based system is used for advancing the technology. And this is called a virtual sieve. Instead of using a physical sieve, image-based system can be used for characterization of sand, gravel, and concrete. So you get the distribution of the material, and from that, we will be able to decide what's the pore structure that is likely to result, how much of material needs to be used. So we will get a better understanding of the raw materials in the conveyor belt in plants. We can reduce the energy demand. We can increase the packing density for the concrete. We can reduce the consumption of the cement, and overall quality can be improved. Another example of the use of image-based system is the virtual reality assessment of roads. This is another example from Northern Ireland. The AME roads, Northern Ireland used laser scanning technology for scanning the bridges. You can see the bridge on the left-hand side and the scan image on the right-hand side. So Crossrail in the UK used the drones to inspect structures. This is the example I've shown here, a building damaged by fire, for site inspections, health and safety inspections, crane, tower and scaffolding inspections, site planning, getting 360-degree panorama of the structure. For all these reasons, we can use drones and image-based technology. And talking about image-based technology, here is another case. It's a cliff edge in Northern Ireland. This work was done by Amy McCabe from Queen's University. And you can see on the left-hand side, it's 60-meter high. The boulder field is inaccessible for doing any surveying. So you can use drones to survey and capture the image, and the photogrammetric models can be built from which you can get really, really accurate measurement of the boulder on the slope. So a combination of artificial intelligence and construction informatics can be used in different projects. And this is a snapshot taken from a publication which you can get it from BIM+co.uk. So digital twins used, and this particular case is actually the Mayfield project owned by Mace, and a particular AI technology pioneered by Disperse is actually being used for the COVID-19 safety, managing the building for COVID-19 safety challenges. So you can see different systems can be used for in combinations for different applications. A brief mention about structural health monitoring and whole life management then. The rationale for structural health monitoring can be seen from this slide. The blue line here is where the construction at the inception, the initial stage itself is of top quality, and slowly the performance deteriorates, but it will never go below the minimum acceptable level. So such a system possibly is used for nuclear containment structures. However, the cost associated with this could be really, really huge. If on the other hand, if you try to save the cost and go compromise the quality at the beginning, you can get actually complete failure, which means that there has to be complete reinvestment in the structure, which would cause huge amount of money to the industry. However, what is normally done is certain level of initial quality is ensured. There will be deterioration with time. At a particular stage, when it reaches the minimum acceptable level, there will be an intervention strategy to restore the structure, and again it will be allowed to deteriorate and then again restored. So this is what is normally done. And the cost associated with this possibly is going to be less than the cost associated with the case one. And how do we get this information? how far it has deteriorated. That information can come from either periodic inspection or putting structural health monitoring systems in place. And that means for early age detection of problem as well as timely intervention and management of infrastructure, structural health monitoring systems can be used. Two examples I want to share with you. This is the Hanju Bay Bridge in China. It's worked on in partnership with the Zhejiang University in China. It's a bridge which is 35.6 kilometers long in very aggressive conditions. For example, the wave height is 9 meters, wind speed more than 30 miles per hour. So we have this service center here, somewhere in the middle of the bridge, and that is where we located our monitoring station. And this is another example. It's a Donark test site in Scotland, where we installed sensors in test pillars and measured the performance of that. Different types of sensors are available, both fiber optics as well as electrical resistance sensors. The fiber optic sensors can be used for temperature, relative humidity, pH, chlorides, and strain. And these are some of the sensors we developed in partnership with Professor Ken Grattan and Thompson's team in City University, London. And then electrical resistivity sensors can be used for moisture movement, chloride ingress, carbonation, chloride ingress, corrosion, and these are sensors developed in partnership with Professor John McCarter in Kirtwat University, Edinburgh. So we can have the monitoring stations, then connecting to remote PC using cloud computing. We get the data, and that data can be used for service life prediction. And depending on how the structure is behaving, intervention strategies can be brought into practice. So the next one then is the building productivity through education and training. So University of Leeds signed a partnership agreement with the Institute of Concrete Technology to offer advanced concrete technology training for graduates, and at the end of that, they get either a PG diploma or an MSc degree. And when somebody gets through that, they can get the MICT, that's the membership grade of the concrete technology. Now, there are three routes to admission. One route is the normal degree route for the MSc, but then there are two other routes which would be really interesting for people working in the industry. One is called experiential route. Say somebody worked in industry for 20 years, and the last 5 years they worked at managerial level. So that experiential training they got can be written in 1,500 words, and we will do the assessment of that independently by two people, and then the admission to this degree is provided. Then the second one is the accredited certificate training. That is, if somebody actually did a number of trainings, CPD trainings, and accumulated training, sufficient training, that also can be used for giving admission. So there are three routes for the admission. So what we are trying to do next is work with the Institute of Concrete Technology to develop online education, which will be available all over the world, and we will provide CPD certification, and the credit accumulation can be used for academic and professional qualifications. So, concluding remarks then, building productivity can be done through partnership. The partnership can be professional institutions and talent societies, like Concrete Society, Institute of Concrete Technology, the American Concrete Institute, RILEM, or possibly the Institute of Indian Concrete Institute and various other organizations. We can work with both domestic and international industries, government agencies, and academic institutions. So this international partnership in construction materials and technologies can result in CPD certificates, module certificates, diploma, degrees, and research and innovation, which will drive more technological advancement which will be accepted in the industry, and thereby the productivity can be improved. So educating the workforce as well as research and innovation put into practice through this international partnership would help in building productivity. And to do that, we need continuous funding from both government and the industry. We need strategic partnerships such as with the high technology companies and IT industries and R&D institutions. We need global partnerships so that pandemic of the type we faced can be addressed, and we can ensure that there is social and economic development in the countries. So as a concluding remark, there is a social, economical, and technological solution for every problem and situation. Timely and appropriate decision-making is absolutely crucial to the success. As shown here, a triangle wouldn't fit well in a circle. A rectangle wouldn't fit well in a circle. A circle will fit well in a circle. So identifying this circle, that is the appropriate technology, appropriate workforce, and the timely intervention strategies, all of them would bring productivity of the construction industry. Thank you very much. Any questions?